Okay, check this out. We're going to do a couple of examples of getting the square roots of functions, and we are going to do one linear and then one quadratic example. We're going to stick to those two types, even though you could technically go further than that, and you can take a look at any type of shape. You can apply what you're going to learn here to get the square root of any type of shape. We're going to stick to just two. So how do you get the square root of this? Well, first of all, we don't even have an equation here. You could get an equation because it's linear, and you've learned how to get linear equations using slope and y-intercept back in grade 10 numbers, I believe. But getting the equation isn't necessary to do this question. Okay, we're just going to work from the graph alone. Okay, and essentially what we're going to do is on top of this graph, we're going to sketch the new square root of f of x function. So what you need to do with these, all right, is you need to pick any point at random. Okay, it doesn't matter where you start. Okay, you're going to pick any point at random. You're going to look at the y coordinate of the point, and you're going to get the square root of that y value. So let's just take one point right here. Let's just start on the very left, even though it doesn't really matter where you start. Let's start with this point right here. That has a y coordinate of 4. Square root of 4 is 2. So we're not moving left or right here, okay? We're just going to move vertically to the new y value. We said the square root of 4 is 2, so we're going to drop down to 2, and that's the new point on our new graph. Okay, that's one point on the graph. We do this a whole bunch of times for different points, and then we can make a new graph. Some of these are going to use some decimal numbers. For example, if we take, we take this point right here, that is a 3. So we get the square root of 3, and that's like approximately 1.71, I believe. Just approximating. We don't really know where 1.71 is. We're just going to estimate it to be right here. Again, when we go from our original point to our new point, we don't move left or right. We just move up or down to the new y value. We're not getting square roots of x coordinates, only y. And then you can continue these a little bit more. Okay, you can say, all right, well, this is a 2 right here. Square root of 2 is approximately 1.4. So we can go down to where we think 1.4 is. So maybe somewhere around right here somewhere. Then we have what is known as the invariant points. The invariant points are when y is 1 and when y is 0. Because square root of 1 is 1, square root of 0 is 0. So this point right here of 1, that is a point on your graph. Okay, you can see right here, okay, that what we have is that's one of the invariant points. In this case, the point would be 0, 1. But we have it on our graph. Okay, square root of 1 is 1, so we don't need to move up or down. And similarly right here, square root of 0 is 0. Now you see the 2 that's there, okay, but that's the x coordinate. We're not getting square roots of x coordinates, only of y coordinates. And then anything that's below the x-axis has a negative y value. And you cannot get the square root of a negative number, so we would just cross that out altogether. You don't actually have to cross it out. You could just not draw a graph there. Okay, but what we would have is now we just connect the points that we have, and it goes a little something like this right here. Now you might say, okay, why did I draw the graph above? Oh, sorry, didn't mean to do that. Just trying to, and for some reason this is not working. I'm trying to, okay, it's because I have a Band-Aid on my thumb. There we go. Okay, this is working, all right. Notice that the graph that I drew, the new graph, is slightly above the original graph from y is equal to 0 to y is equal to 1. Well, that just goes back to when we take a look back here. Remember what we said, the numbers between 0 and 1, the square root of those numbers are actually greater. So what you see is when you go between 0 and 1 for y, the new graph is actually a little bit higher than the original graph. But for any y value greater than 1, what's going to happen is the new graph gets flattened down because the square root of a number is generally smaller. And then we can just write our domain and range, and you can do this the old way if you wish. I would prefer doing it the new way. It's just easier in my opinion. If we look at the x values, it goes to the left to negative infinity, but the right bound, it stops at a positive 2 in this case right here. And then if we look at the range, okay, the new graph does not go below the x-axis, so it starts at 0, but it touches 0, and then it goes up to infinity. Even though it's going up, it looks like it's kind of flat, it's still moving upwards. So we go to infinity like that right there. So we have our domain and range, we have our invariant points, okay, even if we can't get the coordinates of them, what you want to do is at least make sure that they are labeled on your graph. And now we have our new function, the square root of this linear graph.